Hi everyone! Can you all comment and say that you can hear me?
Yes.
Yes, I can hear you.
Hello, Lindsay. Yes, we
Yes,
can hear you.
I enjoyed the person that said hello, Lindsay. That's a common thing. My name's Hazel, but yeah. Welcome
My
everyone.
bad, sorry.
Sorry to mute you, but because there's so many of you, you can obviously still type to me, but otherwise it will be total chaos. So welcome everyone. Can you just tell me which country you're from? Because I would love to see. If there's anything wrong with the technology, we're going to blame Martin for this.
Hi guys, sorry for this. Let me just
So
the chat.
all the
chat.
comments should come up. Pakistan, Qatar, Egypt, Oman, Saudi Arabia. This is awesome. Welcome everyone. Right, in order to do this lesson, you won't need very much. You need a piece of paper and a pen. So does everyone have that? And yeah, good, that's great. And what we're going to do today, as I said, is an introduction to chemistry. Now, chemistry is actually my favorite science, but I do find that people do struggle with it because it's a very logical science. You need to be able to understand, for example, how the periodic table works, and that's exactly what today's lesson is going to be about. So we're going to look at the definition of things like elements, compounds, and mixture, and I'm going to go into a huge amount of detail as to how you can use the periodic table to help you answer as many questions as possible. So let's start first of all by, I'm going to share my screen, and this will primarily be done on my iPad, so you can see, which one do I use? That one, thanks. So I hope, let me know if you can't see this, but hopefully you can see these three states of matter. And crucially, you could be asked in exams to draw the states of matter. It's very important that you notice that in the solid state of matter diagram, that all the particles are touching and you have a very regular arrangement. So let's just make a note here, and feel free to make notes. So fixed arrangement, and the particles are touching. You wouldn't believe how many people don't get marks because they don't show the particles touching, or they're a bit sloppy with how they draw them. With the liquid, notice, it's really important you notice that all the particles here are sitting at the bottom of the little container here. People have a habit of filling the whole container. Well, think about your glass of water. It's not, you don't find that your glass of water is completely filled with water particles. What you find instead is that the particles sit at the bottom of the vessel. We have a slightly scrambled arrangement, but crucially notice that the particles are still touching. And then with the gas, as you would expect, notice that we have a very random arrangement of particles. And the particles do not touch. Now, I know this might seem quite simple, but I'm going to just add something to this because we're now going to start looking at what an element, compound, and mixture are, and then we'll combine all this information to get you guys doing a task. So, an element, let's just switch to here. So notice that an element is a substance which is made up of only one type of atom. This is essential. Too many of my students say that an element contains only one atom. That is ridiculous. An atom is extremely small. And so an element is made up of very many millions of atoms, billions of atoms, but crucially, they all belong to the same type. So, for example, if we look at copper, we can see that it's made up of copper atoms only. Carbon is made up of carbon atoms only. Helium, as we can see from the particle structure, is a gas, but again, it will only contain helium atoms. So let's make a couple of definitions here. In fact, I don't need to change this definition. This definition up here is your perfect definition of an element. The only other thing you could add is that an element cannot be split by any chemical means. And so that's your really full answer there. It contains only one type of atom and it cannot be split by any chemical means. Oh no, was everyone sitting in the waiting room?
There's just a few.
Sorry guys, I blame Martin. Yeah, I'm very prompt, so I did start exactly on time, but I blame Martin. I'm sorry for anyone that was left in the waiting room. Okay, so we've just talked about what an element is. It contains only one type of atom, which cannot be split. So what is a compound now? Well, a compound contains two or more elements chemically combined. And so that means a chemical reaction has to have taken place in order to produce our compound. A good example of this is water. So if we look at our definition of a compound, it contains two or more elements chemically combined. So let's ask ourselves, what's in water? Well, it's the elements hydrogen and oxygen. Notice you can't easily separate your compound into its constituent elements. They are chemically combined. It is a permanent, irreversible process. If we were to take a mixture now, again, we're going to say that it's two or more elements. But crucially this time, they are not chemically combined. And so let's take air as an example of a mixture. Why is it a mixture? Well, it contains two or more elements. Those elements include nitrogen, oxygen, but it also contains lots of other things like carbon dioxide and water. And the reason why air is a mixture is because using the right processes, we could actually separate air into its constituent elements, into its constituent compounds. So let's notice we have a compound which contains two or more elements chemically combined. A mixture contains two or more elements not chemically combined. So now it's time for you guys to do a task. So here we have 5 boxes, and your task is the following. You have to decide for each box if, first of all, we have, going back to what we first learnt about, a solid, liquid, or gas. And then you need to ask yourself if you have an element, compound, or mixture. And so on your piece of paper, make sure you write it on your piece of paper. I don't want anyone to ruin the task for anyone else by typing it into Messenger. Just make a note, label them box 1, 2, 3, 4, and 5. And you've got a minute now to decide whether you have a solid, liquid, or gas, an element, compound, or mixture. Right, let me know when you're ready for me to go through the answers in the Messenger. Okay, so number 1, we have a gas, and that's because the particles are extremely far apart, And we also have an element, and that's because it contains only one type of atom. Did everyone get that right? Is anyone else having problems with hearing? You might need to switch on your, what would they need to switch on?
Their computer audio.
Their computer audio needs turning on. Well done, everyone. Okay, box 2, we have a gas again because those molecules aren't touching. But we also have a compound, and that's because you can see that we have 2 different types of element present. Okay, moving on to box 3, we have a solid due to the close arrangement of particles, and we have an element because we have only one type of atom. Next up, number 4, we have another gas. It contains only one type of atom, so we have an element. And then number 5, we have a gas again because the particles aren't touching, and we also have a compound because we have multiple elements. Just to make a little addition, a molecule, people confuse this a lot, is simply 2 or more atoms bonded together. Now these can be the same atom type or they can be different. So just to go through our various examples again, number 2 is a molecule. Number 4 is a molecule. And number 5 is a molecule. But looking at number 4 and 5 closely, you can see that we have both an element and a compound example here, but that they are both molecules. Is someone drawing on my screen?
I think so.
So weird. How's that happen? Okay, so is everyone happy with that? You've got to be good with your particle diagrams, and I'm hoping this has given you a good example. Yay, thank you for everyone that's replying. It's so weird. I feel like I'm just talking to myself. Okay, moving on now, looking more closely at what an atom actually is. Let's give ourselves some space, so I'm just going to scroll to the...
Sorry, whoever has annotated on the screen, do you mind removing your ticks and lines? I'm not quite sure how to do it from our end.
Is it one person?
I think, well, maybe.
Okay, so looking at the structure of an atom now, notice that atoms are made up of protons, electrons, and neutrons. We're going to take helium as the first atom that we're going to look at. So how are these protons, electrons, and neutrons arranged in an atom of helium? Well, you have a central nucleus which contains protons and neutrons, and then surrounding that nucleus you have what's known as shells of electrons. And sorry, that's really wobbly, but this is exactly how you have to draw the structure of an atom. So just to notice, here's the central nucleus, which contains the neutrons and the protons. And surrounding that, you have what's known, it's so weird, but they're known as shells of electrons. And here's an electron. Now then, what we need to now talk about is the various charges and masses of these subatomic particles. We call them subatomic particles because they are found within the atom. Okay, so here's our table. So we're noticing that we're talking about electrons, protons, and neutrons. We need to notice their charge and their mass. Now, electrons have a -1 charge. Protons, try and remember P is positive. They have a positive charge. Neutrons, remember neutron, neutral, means that they have no charge. Next up, the mass. Now, crucially, the electron mass is extremely small. You'll see it written in slightly different ways in different places, but it is approximately 1 divided by 1800, so it's extremely small. And then your proton has a mass of 1 and your neutron has a mass of 1. So notice here that most of the mass of an atom is found within the nucleus, and that mass comes from both the neutrons and the protons. For Zara, when you've written that it's 1 divided by 2000, this is all an approximation. This number is negligible, which means it's extremely small. So whether you say it's 1 divided by 2000, 1 divided by 1840, it's the same. Okay, so don't sweat that too much. These numbers are all an approximation. But we must notice that the mass is primarily found within the nucleus. And so actually what you can say is this summary, which is that the mass number of an atom is therefore made up of what? Well, it's the proton number plus the neutron number. And now we're going to start introducing a little more information. So I'm going to take cobalt, which is a metallic element, and I'm going to assign these numbers to it. Now, hopefully everyone's familiar with this, but what this means is, first of all, we have the chemical symbol of cobalt, which, don't be sloppy with this, make sure the first letter is capitalized and then the second letter is in lowercase. It's really important. People are quite sloppy. They end up writing things like this. This does not mean cobalt. Can anyone write in the messenger what that means? Does anyone know what that compound is? Capital C, capital O. Yes, very good. Carbon monoxide. Well done, everyone. So can you see with chemistry, it's incredibly important that you're careful, because by writing something which looks basically the same, it means something completely different. So we have cobalt here. Now, next up, the 59 and the 27. The 59 indicates the mass number. The 27 indicates the atomic number. Which happens to also equal the proton number. So there's an awful lot of information we can pull out from this simple cobalt situation. What do we know? Well, we know the chemical symbol of cobalt is CO. We know that its mass number is 59. And we know that its atomic number is 27. So that means, therefore, that we can say that its proton number is also 27. And then hopefully you can work out that the neutron number, therefore, based on the fact that the mass number equals the proton number plus the neutron number, then you need to work out the difference between those two numbers to work out the neutron number. Where's my calculator? So you do 59 minus 27 to get 32. The last thing you can work out is the electron number, which equals the proton number. So that is also 27. So just to make a note up here, the atomic number equals the proton number, which equals the electron number. And then hopefully you can see that because the proton number equals the electron number, this means that atoms are neutral. They have no charge. Why? Because the proton number equals the electron number. So the number of positive charges equals the number of negative charges. So now it's up to you guys to do the following task. We're working out the number of protons, neutrons, and electrons in these elements. Firstly, iron. Notice that iron has a strange chemical symbol. Here's your second example. And here's your third example. So don't write that in the messenger because everyone wants to have a go by themselves at home. I dripped water on my iPad. Okay, 30 more seconds. Thanks, Zara. I'll take that as a compliment. Is everyone finding this helpful? Thank you, Hazel's biggest fan. Okay, so going through iron, number 1, right, the proton number is 26. The electron number, remember, which is the same, is 26. And then the difference between those two numbers is the neutron number, so that's 30. Did everyone get that right? Okay, next up, our proton number is 41. Our electron number is 41. Our neutron number is 52. And then for uranium, our proton number is 92, electron number is 92, our neutron number is 143. How do you say the NB element?
Niobium.
Niobium. I've been very carefully avoiding saying it. Okay, are we ready to move on then? So let's now look at the periodic table. Guys, you have to make the periodic table your best friend when it comes to chemistry. So notice that it is split into metals and non-metals, and that there is a stepped line. I've got to make sure I take the stepped line down in the right place. Can you help me make sure I draw it in the right place? But the stepped line exists around here. I'll draw it more accurately shortly. But notice that the non-metals sit on the right-hand side, the metals sit on the left-hand side. So we have far more metals than non-metals. It's also quite important that you learn what the various columns are called. So a column is obviously this sort of thing. Now, the first column is known as the alkali metals, which means that anyone that's hopefully done some basic chemistry knows that an alkali has a pH of above 7, and hopefully we'll talk about this in another video, but these metals here, when added to water, produce an alkaline solution, which therefore has a pH of above 7. Next up, we have the second column, These are known as the alkali earth metals, slightly less well known than the alkali metals, which form the first column. Then the central chunk of metals, which form most of the periodic table, are known as the transition metals. So they form this part of the periodic table. And then after that, we're really only interested in this column over here. Sorry, my hand's so shaky. These are known as the halogens. And then the last column here is known as the noble gases. So we're just adding, someone at MPW. I teach someone there. So yeah, here we have our various labels that we attach to various columns in the periodic table. Does anyone know what these columns are called? Type it into Messenger. What's the special name we give to these columns? Yeah, well done everyone, good knowledge. These columns are all known as groups. And now, because chemistry, I want you to not just learn stuff off by heart, I want you to understand it. So what do all elements in the same group have in common? Well, let's take lithium, for example, and I'm going to draw its electronic configuration. So I know that 3 is the number of electrons that lithium has, and hopefully from my teaching, you'll know that that's true. And then just to show you what lithium looks like when we draw the electronic configuration, it's just, I don't want to overload you, but when you're drawing the shells of electrons, remember that you have 2 electrons that go into the first shell, and after that you have a maximum of 8. So that's what lithium looks like if you draw it out. Taking another element, sodium, which is in the same group, if we draw sodium, no, I'm going to run out of space. I always do this. Oops. Oh, it's going to end up being a mess. That's stressful. No. Sorry, this is so horribly drawn. But if I draw sodium next door, hopefully you can see that you have the same number of electrons in the outer shell. So that's what groups have in common, and that is so important. They'll ask you that in the exam. What do they have in common? They have the same number of outer shell electrons. And so if I highlight that here, oh no, I deleted it. There you have 1 electron, there you have 1 electron. So what do elements in group 1 have in common? Well, they have 1 electron in their outer shell. What do elements in group 7 have in common? Well, they have 7 electrons in their outer shell. Okay, has everyone drawn that? And then I'll move on again. So I'm just going to tidy up my periodic table a bit. This app is so good, it's Notability, and I love it. Okay, so I'm going to move on now to look at what a period is. So where we said, hope I haven't done that too quickly. So what is a period now? Well, it is a horizontal row in the periodic table. So really we're looking here, these elements are all in the same period, as are these. So let's take beryllium as our example. We can see that it has 4 electrons. So I'm going to draw its electronic configuration. And then I'm going to compare it to carbon, which has 6 electrons. notice how I'm filling up my shells. You draw pairs of electrons at 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock. So if we sit back and try and work out what's similar about these two elements, well, you can see that they both have two shells of electrons. Here's a shell, and here's a shell. 1, 2, 1, 2. So let's make that note about elements in the same period have the same number of shells of electrons. Okay, I'm about to set you guys another task, so do let me know in the messenger. It will just be shy of 40 minutes because that's how long Zoom lets you run a class for. So let me know when you're ready for the next task. Oh, thanks everyone that says they want more lessons. I was like a nervous wreck. Okay, so the next task. I'm losing my voice. So the next task. Oh, thank you. I'm gonna cry. Okay, so you're only using elements from the following list. Cesium, chlorine, moly, oh gosh, no, I can't say that. I'm not going to say that. Neon, nickel, nitrogen, and strontium, and tin. By the way, you will need the periodic table. So I don't know if you can take a photo of this one, or have you got your textbook, or have you got another page open online? Please get a picture of the periodic table because you need to be able to refer to it to answer these questions. No, who has been drawing on my periodic table? How do I get rid of them? Who's this person? Oh man. Has everyone got a periodic table? Okay, I'm assuming that everyone has a periodic table. So we're using elements from the following list to state the following. Right, first of all, I want you to state an element from that list which is in group 2. Do it on your own, by the way, because we don't want everyone like missing out if you write it in the messenger. B, find an element in that list which is in the same period as silicon. C, find an element in the same group as phosphorus. D, find an element which is in period 6. Okay, because we're running out of time a little bit, I don't know where the time's gone, I'm going to start going through the answers. So an element in group 2, you need to look down that vertical column in group 2 and you'll see that it is, I need to check myself, strontium. Did everyone get strontium? Well done everyone who got strontium. It's here and it's in group 2. Next up, in the same period as silicon, so you're looking across the silicon row, because remember it's the horizontal row, and which was in the list? I'm trying to read them myself now. I can't spot it. It's chlorine. Yeah, chlorine. Okay, next up, in the same group as phosphorus. So phosphorus is here, so we're looking along this, down this column. And then in terms of the list, we had nitrogen mentioned there. Guys, don't write your answers, it's not fair on everyone else. And then lastly, period 6, we're looking along 1, 2, 3, 4, 5, 6. We're looking along this one. So it's actually quite a difficult task. You're looking here for cesium. So I quite like chemistry because it's a bit like solving a puzzle. Right, everyone, let me know, how did you find that? Did you enjoy it? It'd be great to get some feedback or how you would like me to do it differently next time. But yeah, I really hope you found it helpful. Yay, that's some really positive feedback. I was so nervous. Did you guys enjoy chemistry? Do you see what I mean about it being like a puzzle? So although it looks fairly simple when we started, you keep building your knowledge, you understand how the periodic table links. Yeah, and as long as you can understand that, then you don't have to do too much rote learning. The periodic table tells you everything. Okay, so I'm going to sign off now. Look out on my Insta page for the announcement for the next online class. And yeah, let's do this together while we're staying at home. I hope everyone's well. Oh, and lastly, I know these are completely free, and they are, but we are raising money for the NHS, which is the National Health Service in England, and they're doing an amazing job. So if you did want to donate at all, then the link is on my website. So yeah, thank you so much for joining, and we'll be back soon. Bye, everyone.
6 waiting in the waiting room.
Okay, admit them.
8. Oh, cool. Ready? We're going to make the.
So what happened now? Can they hear me? No, I don't want to do it.
Ready?
There's so many.
That's awesome.
No, I don't want to.
You ready?
No. Ah!
1. Yeah.
Okay, and now we have to write.
Yeah.
Hi.